All right, part 2. This is the review for Unit 3 of Math 2. We left off at number 12. We're starting up at number 13. So, in number 13, we're comparing triangle ABD to triangle DCA. Okay, and if you notice right away that we have this angle C is marked the same as that angle C. Okay, so that means that in number 13 we have a definite pair of angles that are equal to each other, so I'll put an A down there. And then we also, and that's it. So those are the only congruent marks that we know for sure are equal to each other in number 13, but you should see right here that side AD is equal to itself in both of the triangles. So that gives me a pair of congruent sides. Even though it looks like it's only one side, since that side A to D is in both triangles, that means it's equal to itself. Okay, well, that's still not enough information, because remember, I'm trying to figure out which postulate or which rule is going to make the triangles congruent. Okay, and so what I need to do is I need to use these arrows right here to help me get some more information. So these arrows tell me that line A to B, no matter how long it is going to be parallel to line C to D. Okay, so all that means is that those two lines, they'll never touch each other. Well, if you notice, what we have here is we have a transversal which cuts through or intersects these two parallel lines. Okay, and that would make that angle right there congruent to that angle right there, because those angles are alternate interior angles. So that gives me another set of angles. Okay, so if you notice, let's just focus in on the top triangle right now. We have two angles. We have a side, but the side where the tick mark is opposite of the two angles, so the reason would be angle, angle, side for number 13. Okay, that would allow me to write a congruency statement of triangle ABD. I'll go ahead and call the top triangle ABD, and that's going to be congruent to triangle, and the order we write the first triangle does not matter, the order we put the letters in, but the second triangle, it matters. So what's the same as A, but in the bottom triangle, that would be D. What's the same as B in the top triangle, but in the bottom triangle, that would be C. What's the same as D in the top triangle, but in the bottom triangle, that would be A, so that would be my congruency statement. Moving on to number 14, the one thing you should notice right away is that since this angle is 90 degrees, the angle that makes a linear pair right next to it has to be 90 degrees, okay? So what we have is, in number 14, we have right triangles. And once again, whenever I have right triangles, I immediately cue in on and I see if the hypotenuse leg or the HL rule is going to work. Okay, so are the hypotenuses equal? They are, by those tick marks right there. Is either one of the legs equal to each other? And you should see right here that this leg is equal to itself in both of the triangles, so the HL rule would apply to number 14. So now I'm going to write a congruency statement. I'll start with the triangle on the left. I'm going to call it triangle JKM. I could have put those three letters in any order I wanted to. Then I'm going to say it's congruent to triangle, and now the order of the letters that I put here have to match up. So what matches up with J? That would be L. What matches up with K? Well, that would be K in the other triangle. And what matches up with M? That would be M in the other triangle. So there is my triangle congruency statement. Moving on to number 15, you can see right away I'm comparing triangle NML to triangle, I think that's a Q, QPL. Could be an O, who cares, right? So we know right away, notice right away, we have those tick marks right there. So that tells me I have a pair of congruent sides, so I'll put an S. Then I have this mark is the same as that mark, so that's telling me those two angles are congruent, so I have a pair of congruent angles. So I have an S, based on the marks, I have S and I have an A. Well, there is no SA rule, there is no AS rule, so I have to get more information here. And what you should notice is that we have vertical angles. Vertical angles are always equal to each other. So therefore, I have another A in number 15. All right, well, now let's see what's my postulate or what's my rule that would work. So let's just focus in on the bottom triangle. So notice I have these two angles here. And then I have this tick mark for the side, and the tick mark is opposite the two angles, so number 15 is going to be angle, angle, side. Okay, now I could write a congruence statement. So triangle, I'm going to name the top triangle in any order I want. I'll put it in alphabetical order, LMN. That is congruent to triangle. Now when I name the bottom triangle, I have to match up. So what matches up with L, but in the bottom triangle, that would be L as well. What matches up with M, but in the triangle down here, that would be that Q. Let's assume it's a Q. And then what matches up with N, but in the bottom triangle, that would be P. So there is my triangle congruency statement. Okay, moving on to number 16, 17, and 18. We're doing the same idea in 16, 17, and 18. We are just, what we're doing is we are writing, determining if the triangles are congruent, giving a rule, and then after we give the rule, what we're going to do is we're going to write a congruency statement. Okay, so number 16, we're comparing triangle QPR to triangle SRP. So right away, you notice that we have that angle marked the same as that angle. So that means I have a pair or a set of equal angles. I have these double marks right here, which gives me another pair or another set of equal angles. And then based on the marks in the picture, I don't have any other information. However, we do know that side PR is equal to itself in both of the triangles, so that gives me a side. So notice I have an angle, a side, and an angle in each one of the triangles. So my postulate, or my rule, that makes the two triangles congruent, number 16, is angle, side, angle. So now I could write a triangle congruency statement. So I'm going to say triangle, and I'm going to name the top triangle in any order I want. P, Q, R. I'm going to put the congruent sign, I'm going to put the triangle sign, and now I'm going to name the bottom triangle in the matching order. So, what matches up with P, which has the double mark, but in the triangle on the bottom, that would be that double mark, which is R. What matches up with Q, which has no mark in it, that would be S. What matches up with R in the top triangle, which has one mark, that would be P in the bottom triangle. So there is my triangle congruency statement for number 16. Number 17. You can see right away we have enough marks in order to come up with maybe a reason. But the problem is here is that I have that side is marked the same as that side, so I have an S. I have this side is marked the same as this side because of the single tick mark, so I have another S. And then I have angle Z is marked as congruent to angle L, so I have an A. Okay, so I have two S's and an A, but here's the problem. Whenever you have two S's and an A, your only choice is side, angle, side, or it could be angle, side, side. And remember, angle, side, side is that is not a rule. Okay, so side, angle, side means, let's look at this triangle here. Is that angle in between, or is it included between the two sides? It is not, so it's not side, angle, side. So this is actually angle, side, side, which is not a rule. So that means in number 17, there really is not enough information for me to determine if the two triangles are congruent. Okay, number 18. So right away, you notice in number 18, what's given to me? Well, I have right triangles. Okay, so remember, whenever I have right triangles, the one rule that always works for right triangle, not always works, but is specific to right triangles only, is the hypotenuse leg theorem. So are the hypotenuses equal to each other? And you can see that they are not. So that means that even though this is a right triangle, I can't use hypotenuse leg. But I'm going to see if any of the other rules work. So notice I have a tick mark here and a tick mark here. So I have a side that's equal. It's still a right triangle, but I can't use HL, so I'm going to cross it off. I have a double tick mark here and here, so I have another side. And then I have these 90-degree angles, and they're equal to each other, so I could treat that as an equal angle. So I have two sides, I have an angle, and notice the angle is included in between the two sides, so this would be side, angle, side. Okay, and then I'm going to write my congruency statement. So I'm going to say triangle, and I'll name this triangle. I'll go ahead and name it BCA. That's going to be congruent to, and then I'm going to name this triangle here. I'm going to match up. So what would match up with B, but over here, that would be F. What would match up with C? That would be D. They're both right angles. And then what would match up with A, but over here that would be E. So there's my triangle congruency statement. Okay? All right, moving on to number 19 and moving on to number 20. What we have here is we're writing a proof. So if you notice, the first thing that we have is, so if we have the proof, we are given that side A to E is congruent to side C to E, and that's marked, so I'm going to write that as my first statement. Remember, the first thing you do when you write a proof is that you always write the given first. We are also told that side A to B is congruent to side C to D. That's shown by those single tick marks, so I'm going to put this in my first given as well. Now, sometimes you can combine the givens if they're saying the same thing into one statement. Other times, if you want to, some people would have added another statement here. Statement number 1 for that first given, statement number 2 for that first given. But both of these reasons are given here, okay? Then notice statement number 2, the reason is given, and if you notice, I had that given, but I have a third given. So my third given, which I'll write as statement number 2, is E is the midpoint of line segment BD. Now, because I did not specifically say in statement 2 something was congruent to something else, I'm not going to add any tick marks in my picture yet. Okay, but now this is where I have to use my understanding of geometry. Okay, so I'm using the word midpoint right here. So what does that word midpoint mean? Now remember, we had these notes right here, and we said in our notes the definition of midpoint is a midpoint will create two congruent sides. So because E is the midpoint of BD, that means it creates these two congruent sides here, B to E and D to E. And that would be my third statement, that side B to E is congruent to side D to E. And what is my reason for that? Well, that was the definition of midpoint. Midpoint creates two congruent sides. Okay, my statement number 4, if you notice, my last statement that I always write in my proof is exactly the same as what I'm actually trying to prove. And so now what is my reason? Well, I have side, side, side. So my reason for this proof would be side, side, side. So that would be an example of how to do a proof that was partially filled out for you. Number 20, same idea. We have a proof. We are given that side A to B is parallel to side D to C. We're also given that angle B is congruent to angle D, and you could see in the proof, whoever wrote this, whoever typed this up, they wrote both of those givens in the first statement, and the reason for that was given. Okay, so they did that. And then if you notice in the picture, they marked that A to B was parallel to C to D with those arrows, and then they marked that angle B was congruent to angle G with the arcs there. Okay? All right, so now statement number 2 says that the measure of angle BAC, so let's go ahead and mark that. BAC would be right here. That is congruent to measure of angle ACD, so A to C to D, that would be that angle right there. So this is saying, statement number 2 is saying those two statements are congruent. Okay, well, what's the reason for that? Well, if you notice, these two angles are inside the parallel lines, but they're on alternate sides of segment AC. So the reason for this would be alternate interior angles. Okay, AIA. AIA is always a reason that we could use to say two angles are equal to each other. Okay, then we move down to statement number 3. Notice reason number 3 is given, and it's reflexive. So the reflexive is when you have a line segment like that, A to C, and it's equal to itself. So this statement right here would be line segment A to C is congruent to line segment A to C. Okay, that would be the reflexive property. And then the last statement, I crossed out number 5. The last statement is we're literally writing whatever we're trying to prove, which is triangle ACB is congruent to triangle CAD. And my reason is going to be one of those 5 rules that we have. So what do I have? Let's focus in on this bottom triangle. Notice I have 2 angles that are equal. I have a side, but that side where the tick mark is opposite of the 2 angles, so my reason would be angle, angle, side. Okay? All right, number 21. Number 21 is probably the most challenging proof of all, and the reason is because it's not partially filled out. So in number 21, we're expected to fill out the entire proof. So let's go ahead and do it. Okay, so we are given that angle K is congruent to angle M. Okay, so that is my first given. So the first statement that I'm going to write is my first given. Angle K is congruent to angle M. That reason is, that is given. And what I'm going to do is I'm going to look at my picture and make sure that angle K is marked congruent to angle M. It already is. Somebody did that for me. My second given is side K to L is congruent to side M to L. And that would be, my second reason would be that was given to me. Now let's make sure that that's marked. Side K to L, there it is, right there. It has that single tick mark, is congruent to side M to L. So that was already marked for me as well. Okay, so now I'm going to go to statement number 3. Okay, so what I have right now, if you notice, I have a pair of equal angles and I have a pair of equal sides. And I'm going to prove that triangle JKL is congruent to triangle PML. Okay, and so, but I don't have enough information yet. So I have to come up with something that I know must be equal in the two triangles, must be congruent to each other in the two triangles, even though they don't have any marks. And you could see right here, we have vertical angles. Vertical angles are always equal. So statement number 3 is going to be, I'm going to name those vertical angles. So I'm going to say angle, and I'm going to name this top vertical angle, JLK. Okay, that angle is congruent to the other vertical angle, which is down here, and I'm going to name that as PLM, angle PLM. And my reason why those angles are congruent is because I have vertical angles. Vertical angles are always equal to each other. Now I have enough information to make my fourth statement, which is that triangle JKL is going to be congruent to triangle PML, and my reason for that would be, notice I have two angles in each triangle that are equal, and the side that's marked as equal is in between the two angles. So my fourth reason would be angle, side, angle. Okay, number 22. 22 says, name a common angle. Let's make sure you can see it first. There we go. Name a common angle for triangle TPQ and triangle RPV. And what we have here is we have overlapping triangles. So let me just show you the two triangles we are talking about. TPQ is that triangle right there. So what I'm going to do is I'm going to take that triangle and I'm going to redraw it. I'm going to separate it. And I'm just going to redraw the triangle outside of the original picture, putting in the letters. So the top point is P, P goes to Q, Q goes to T. I kind of went into this next problem, no big deal. Okay, and then I'm going to compare that to triangle RPV. So here's RPV right here. And what I want to do is I want to redraw that triangle separately from the picture. Okay, and the reason why you want to do this is because ultimately this is going to help you see much more clearly the whatever we have in common. We're going to be looking for a common angle. So R goes to P, P goes to V. Okay, and then this problem says name a common angle for these two triangles. Okay, well, so that means what I'm doing is I'm looking at each angle and I'm looking at the letters. So you see we have a T and we have an R. Those aren't common, they're totally different. Here I have a Q and I have a V. Well, those aren't common, those are totally different. But if you notice up here, I have common angles. I have a P and I have a P. So right there is my common angle. Okay? And so here are my choices. So which one of those choices would name that angle? Okay, notice it's got P. Well, P is in the middle. So if I use three letters, P has to be in the middle because P is the vertex. So this is my only choice right here. TPQ. Notice TPQ. So number 22, that common angle would be D. Okay, number 23. 23 wants us to name a common side for triangle RST. So here is triangle RST. T. So what I'm going to do is I'm going to redraw that triangle. I'm going to separate that triangle from this picture. So I have R going to S, S going to T, T going back to R, and I have triangle UTS, UTS. So I'm going to redraw that triangle. I'm going to separate that triangle from the picture as well, and it's going to look like this, where we have U going up to T, T going across to S, and then S going diagonal back to U. Okay, so now I'm looking for a common side. So let's look. I have side SR. Is there a side SR over here? No. I have an ST. Is there an ST over here? Yes. So you can see right here the common side between those two triangles is that side right there. So that answer to number 23 would be D, just like number 22. Okay? And in my opinion, to do these type of problems, when you have triangles that crisscross or overlap each other, it is always best to separate the triangles. Okay, number 24 and number 25, what we have is, we have name a pair of, let's read the instructions, name a pair of overlapping triangles, okay, and then we're going to state whether they are congruent by side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. Okay, so, and then notice in number 24, we're given some information. Now, my suggestion is, before we mark that side A to D is congruent to side B to C, let's go ahead and separate the two triangles, and then it'll probably be a lot easier to make marks, and also it'll be a lot easier to determine which triangles, whether the triangles are congruent. So here I have an A goes to D, D goes to C, C goes back up to A. The other triangle is B going down to C, C going over to D, and then D going diagonally back up to B. Okay, so let's use these two triangles instead of this total picture here. This will make it easier. So side A to D is congruent to side B to C. Okay, and then we have angle A to DC. So start at A, take the turn to D, go to C. That's that angle right there. That is congruent to BCD, which would be that angle right there. Okay, well, if you notice, we don't have enough information yet because we have a side and we have an angle. Okay, so what we want to do is, somewhere in this picture, there'll be a common angle or a common side. And you should see right here that this side right here, D to C, is the same. They're common. That's the same side. So that means it's equal to itself. So my reason would be side, angle, side. Okay, so what are the two overlapping triangles? That was part A, where it said name a pair of overlapping triangles. So DAC is congruent to, and let's put the letters here. So that would be CBD, triangle CBD. Okay? So that's how we would do it. Number 25, we're going to do the same idea. So once again, we are given some information. We're given that side J to K is congruent to K to L, but before I make the marks, I'm going to separate the two triangles that overlap. So we are talking about triangle MKL, so I'm going to separate that triangle and just redraw it outside the picture. More or less looks like that, where we have M going up to K, K going down to L. And then my other triangle would be this triangle here, KNJ. So I'm going to separate, I'm going to draw that triangle as well. So I have K going down to N going across to J, and then J going back up to K. So these are the two triangles that I'm comparing, I'm separating. Okay, now before I complete my statement and before I say whether they are congruent, I'm going to make marks. So I know that side J to K, right there, is congruent to side K to L. I know that side K to N, put a double tick mark, is congruent to side K to M. I'll put a double tick mark. Okay, and now I need another bit of information. All I have is a side and a side. So I'm looking and I'm seeing, are there any sides that have the exact same letters? They don't. Are there any angles that have the exact same letters? And if you notice, we have a K and a K. So that means that angle right there is equal to itself. So the triangles are congruent because of side, angle, side. So that would be my reason right there, side, angle, side. And then let's complete the statement. So MKL, triangle MKL, MKL is congruent, and that would be to triangle NKJ. Okay, so that's how we would do number 25. All right, number 26. We're going to graph a triangle whose vertices have the coordinates A, 3, -1. So I'm going to graph these. So A, 3, -1 means right 3, down 1. There's A. B, 5, -1. So that means right 5, down -1. That's where B is going to be. And then C, coordinates of 4, -3. So that means right 4, down 3. C, okay? So this is a triangle. So here's my triangle right here, ABC. So we are going to take this triangle, we're going to graph it, and I just did that. Then we're going to reflect it over the y-axis. And then we're going to name it A prime, B prime, C prime. Okay, so remember, what does the word reflect mean to do? Reflect means that we are going to flip this triangle over the y-axis, okay? And here's my y-axis right here. So remember, when we reflect something, the distance at each point stays that it is from whatever the line is, and that's the line that I'm reflecting. It'll stay the same distance, but on the other side. So in other words, when I move A is 1, 2, 3 spaces from the y-axis. It's on the right, so when I reflect it, it's going to be 3 spaces on the left. That's where my A prime is going to be. B is 1, 2, 3, 4, 5 spaces from the y-axis. So that means B prime will be 3, 4, 5 spaces on the other side of the y-axis. There's B prime. C is 1, 2, 3, 4 spaces from the y-axis. So C prime will be 4 spaces on the other side. So that right there would be my triangle A prime, B prime, C prime. A reflection of triangle ABC over the y-axis. Okay? Number 27. Now in 27, we're going to graph a triangle whose vertices have these following coordinates. Then we're going to rotate it 90 degrees clockwise. Then we're going to translate it x plus 2, which means right 2, y minus 1, which means down 1. Okay, and then we're going to name it triangle A prime, B prime, C prime. Okay, so the first thing I'm going to do is I'm going to plot these points and connect them to make a triangle. So A is at -2, 1. That means left 2, up 1. I'll put the letters in a second. B is -4, 3. So that means left 4, up 3. And C has coordinates of -4, -1. So that means left 4, down 1. Okay, so there's my A. There's my B, there's my C point. I'm going to connect them in order to make the triangle. Now what I'm going to do is I'm going to walk away from the picture for a second. Sorry, I had to walk away because I had to grab a piece of tracing paper. You can see there's my tracing paper. And I'm going to use this tracing paper in order to do my 90-degree rotation clockwise, okay? So remember, when you're doing a rotation, tracing paper definitely comes in handy. So what you do is you trace your pre-image, and your pre-image, that's your original shape. That would be A, that would be C, that would be B. And then you also trace the y-axis and the x-axis. And then what you're going to do is, the word rotate means I'm going to turn the shape. And I'm going to turn it clockwise, 90 degrees. So I'm going to turn it to the right, and I'm going to keep turning it until the axes line back up to right there. Okay? So that's where, when I rotate the shape 90 degrees, that's where my shape is going to end up. Okay, but I'm not done, because the next thing that I'm going to do, and let me kind of fold this paper over a little bit, I'm going to translate this triangle, x plus 2, so that means right 2 units, 1, 2, and then y minus 1, that means down 1 unit, 1. Okay, so that's where my shape is going to end up. So what I do is I poke holes at each one of these points right here. I'm pressing down really hard on my tracing paper to poke holes, and then I'm gonna, you could see, I'm gonna connect them, and that's where my new shape is going to be. So my new shape is gonna look like that, where I have A prime, B prime, and C prime. Okay, so that's how we would do number 27.